In this CBSE flashcard video, we will learn the following topics from matter in our surroundings: properties of liquid and gases, comparison of states of matter, melting, vaporization, condensation and freezing, sublimation and deposition. Let's start with the flashcard number 23. Flashcard up to number 22 were covered in part 1 of this chapter. Next, we will understand how liquid and gases are classified. What are liquid and gases together called, and why? They are called fluids because they can flow. If it flows, it is a fluid. Now let's see why gases in the water are important. Why is the ability of gas to dissolve in the liquid important for aquatic life? Because the oxygen and carbon dioxide dissolve in water, providing the essential gases for aquatic plants and animals. Remember, fish breathe oxygen from water. If there will be no dissolved gas, no aquatic life. Let's compare the diffusion speed. How does the rate of diffusion in liquids compare with that in solids? The rate of diffusion in liquid is higher than in solids because particles in liquids move freely and have greater space between them. Example: ink spreads in water faster than copper sulfate particle that diffuse slowly from solid crystal into water. Now let's observe a gas property. What property of gas is observed with the gas cylinder used by balloon seller? A large volume of gas can be compressed into a small volume inside the cylinder and used to fill many balloons, showing that gas are highly compressible. Next. Why does a gas exert pressure? Particles of gas move randomly, hitting each other and the walls of container. The pressure is force exerted by these gas particles per unit area. Let's compare compressibility of all states. In the experiment using syringe containing air, water and chalk, what is observed upon pushing the pistons? And what conclusion is drawn about the compressibility of the three states of matter? It is observed that the piston compresses the air easily, the water only slightly and the chalk not at all. This leads to the conclusion that the gas are highly compressible, liquids are slightly compressible and solids are incompressible. Now we will compare all the three states together. Summarize the properties of three states of matter. Solid. They have definite shape, distinct boundaries, fixed volumes and are rigid with negligible compressibility. Example: wood, iron, stone. Liquid. They have no fixed shape but a fixed volume, are not rigid and can flow, have very little compressibility. Example: water, milk, oil. Gases. They have neither fixed shape nor a fixed volume. They are highly compressible, diffuse very fast and exert pressure on the walls of container. Example: oxygen, carbon dioxide, LPG gas. Let's see how particles are arranged. Compare the particle arrangement in solids, liquids and gases. In solid, particles are most ordered. In liquid, particles are arranged in layers and can slip and slide over each other. In gases, there is no order and particles move randomly. Now we'll see the force of attraction. Compare the force of attraction in solids, liquids and gases. Force of attraction is maximum in solids, intermediate in liquids and minimum in gases. Next is the space and energy. Compare the interparticle space and kinetic energy in solids, liquids and gases. Both are minimum in solids, intermediate in liquids and maximum in gases. Now we move to change of states. What happened to kinetic energy of particles when solid is heated? On heating, the kinetic energy of particle increases, they vibrate faster, overcome attraction forces and move freely, changing solid into liquid. Example: ice melts into water on heating. This process has a name. What is the process of conversion of solid into liquid called? It is called fusion or melting. Example: ice changing into water. Let's define fusion clearly. What is fusion? The process of melting, that is, the change of solid state into liquid state. Now an important exam term. What is latent heat of fusion? It is the amount of heat required to change 1 kg of solid into liquid at atmospheric pressure at its melting point without changing temperature. Example: heat absorbed by ice at 0 degrees Celsius to become water at 0 degrees Celsius. Next. Define melting point. The temperature at which solid melts to become a liquid at atmospheric pressure is called melting point. Example time. What is melting point of ice? The melting point of ice is 273.15 Kelvin, that is 0 degrees Celsius at 1 atmospheric pressure. Next. Why does the temperature remains constant during melting? The heat supplied is used to overcome the forces of attraction between the particles. This energy is absorbed without a temperature raise and is called latent heat. Next. What does melting point indicate? The melting point indicates the strength of force of attraction between the particles of the substance. Next. What happens when a liquid is heated? Particles gain kinetic energy, move faster, overcome the force of attraction, and on sufficient heating change from liquid to gas. Example, water heated to boiling forms steam. Next. What is the process of conversion of liquid into gas called? It is called vaporization or boiling. Next. What happens when liquid is heated? Particles gain kinetic energy, move faster, overcome attraction and break free, changing liquid into gas. Example, water is heated to boiling forms steam. Next. What is boiling? Boiling is bulk phenomena where particles from the bulk of the liquid gain enough energy to change into vapor state. Next. Define boiling point. The temperature at which a liquid starts boiling at atmospheric pressure is known as its boiling point. Next. Why does the temperature remain constant during boiling? The heat energy is used to overcome the forces of attraction between the particles to change them into vapor without raising the temperature. This is the latent heat of vaporization. Next. What is latent heat? The heat energy that is absorbed or released during a change of state without a change in temperature. The word latent means hidden. Next. What is latent heat of vaporization? It is the amount of heat required to change 1 kg of liquid into gas at atmospheric pressure at its boiling point without change of temperature. Example, heat absorbed by water at 100 degrees Celsius to form steam at 100 degrees Celsius. Next. What is the boiling point of water? The boiling point of water is 373 Kelvin, that is 100 degrees Celsius at 1 atmospheric pressure. Next. What is the physical state of water at 250 degrees Celsius? It is in the gaseous state as this temperature is far above its boiling point at 1 atmospheric pressure. Next. What is the physical state of water at 100 degrees Celsius? It can be in both liquid and gaseous state as this is its boiling point at 1 atmospheric pressure. Next. What is condensation? The process of conversion of gas into liquid on cooling is called condensation. Example, steam changing into water droplets on a cold lid. Next. What is solidification or freezing? The process of conversion of liquid into solid on cooling is called freezing. Example, water changing into ice at 0 degrees Celsius. What is sublimation? Give examples. Sublimation is a change of state directly from solid to gas without changing into liquid. For example, camphor and ammonium chloride change directly to vapor on heating. Next. What is deposition? The process of conversion of gas directly into solid without becoming liquid is called deposition. Example, formation of froth. Next. What two factors determine the state of substance? Pressure and temperature. How can a change of state be brought about other than by temperature? A change of state can also be brought about by changing pressure at constant temperature. Example, increasing pressure converts the gas into liquid. With this, we come to the end of this video. You have now understood the effect of pressure on the change of state. In next video, we will continue with remaining topics of matter in our surroundings, including case study of carbon dioxide, evaporation, condensation, and heat absorption. Thank you for watching this video. If you like it, please subscribe to the channel so that you do not miss any part of the chapter.